Hello, my name is Cesare Oliviero Rossi. I am professor of the University of Calabria Chemistry Department. My research topic concerns the chemistry of the bitumen. I will be about the physical chemical evaluation of the surfactant on the bitumen structure in terms of understanding the mechanism of action of the surfactant to reduce the viscosity of the concrete asphalt. The presentation will be done by me and my co-worker Paolino Caputo. The bitumen is a colloidal system, usually is a complex system, but we can modelize it in terms of asphaltene, the rigid part of the bitumen, the polar part of the bitumen, and the maltine, the oil part of the bitumen, the viscous part of the bitumen. Usually the asphaltene, the rigid part, are the spherical, some aggregate dispersed in the maltine, in the oil maltine. Consequently, we can consider bitumen like a colloidal system, and we can treat this system in a simple way. In this slide, you can see the asphaltene dispersed in the maltine. Of course, the asphaltene is polar, the maltine is apolar. We need some resin that surround the asphaltene to stabilize the system. Which is the problem? Usually, when the asphalt is created, you mix bitumen and aggregate. Usually, the bitumen is around 5% of the asphalt concrete. It is the binder of the system. When you mix this, usually you mix at a high temperature, around, let me say, 180 degrees. So we have a lot of energy that we need to do this process. There is some technology we call warm mix asphalt that by additive, in general they are surfactant, the new generation of this compound, reduce the viscosity of the asphalt concrete, so you can process the system not at 180 degrees, but for example 120 degrees. In this case, you save energy, you use environmental green process. Consequently, the government, the stakeholder push in this direction to find the new compound that have this property, that give this property to the asphalt concrete. But until now, nobody understood the mechanism, the real mechanism of the action of this compound, of this surfactant. So usually this field should belong to the engineering. Now we give a new approach to this system because we are chemistry, so we can understand, want to understand the real mechanism in molecular terms. We use different technique for to understand this effect. One is DSR, rheology. Another one is a scratch test, DMA, and atomic force microscopy. Really, we speak about the contact angle technique instead of the atomic force microscopy. Which is the DMA? The idea is this. The problem is this: when we analyze the data in literature, the surfactant usually doesn't change the rheology of the bitumen in general, but change the rheology of the asphalt concrete. So we prepare some small sample of the asphalt concrete, mixing bitumen and the filler, and we use the DMA, is the rheology for the solid system, to understand if some property change. Look here. This is the frequency sweep of the asphalt concrete, this model of asphalt concrete obtained by mixing bitumen and filler. When the additive, the real additive, is added to the mixture, look, the profile of elastic modulus E prime and the viscous modulus E double prime change is lower. This is just a demonstration that the asphaltene change the property of the asphalt concrete and not of the bitumen. In this slide we perform the result of the temperature test for the bitumen and filler and additive too. In this test usually we record the G prime and G double prime in temperature, and so we can observe the transition temperature from viscoelastic system to liquid system. In this table we can see that of course when the filler the viscosity is the higher one, but with the additive, okay, just the additive, the viscosity little bit increase with A and B surfactant. Let me say about the surfactant. A, B, and C are three different surfactants used in the market for this kind of technology, and we want to compare the result. In this case, if you observe the C additive increase a lot of the viscosity of the bitumen, this is not good in general, while the AB additive increase not so much. When we put this with the system with the filler 2, the viscosity more or less is similar to the system without the additive, and this is quite good. So here we analyze the flow curve of the bitumen with the additive. Anyway, we observe that the additive C is a viscosizing effect on the bitumen and the mastic. So in general, in this case, we observe that the AB surfactant is different from C, and by rheology we can distinguish these two effects. So we can say that the C is changed too much, in my opinion, the viscosity, the rheology of the bitumen of the mastic. The similar situation is at 110 degree, and similar situation in 120 degree. Now we approach this topic with a new technique nobody used until now. The technique is the scratch test. So we use this system. So we let me say the tip where is move along of the surface, giving some force, tangential force, and to understand what happened in terms of interaction substrate and bitumen. So we prepare the sample. The sample is so some aggregate is immersed in resin. After with some mechanism we flatten the surface. We put over some bitumen. The thickness is around 0.5 millimeter, and after we put in the machine, in the instrument. Look at what happened. We use two different of the aggregate to understand the interaction, basalt and the limestone. In this case, you see the profile. When you see the profile, if you look the C additive, the profile shows some peak, let me say, some signal, strange signal. It means that during the traction of the tip, something happened. So there is some exfoliation, let me say, of the bitumen and the aggregate. So it means that the additive is no good for this system, because don't give the good interaction between concrete and the bitumen. Look here, A, for example, is a new nice profile, the B also, but C is very is very bad. So what it means that during by this technique, by the rheology and the scratch test, we can say that what we demonstrate that the DMA indicate that the effect is real on the structure of the asphalt concrete. The additive act as to lower the rheological moduli, the viscous and the elastic modulus. The scratch test show that it is possible to understand which is the best surfactant for that, because the surfactant does not give any exfoliation process during the test, so no peak is observed in the profile curve. About the contact angle, my colleague Paulino Caputo will speak about.
Good day to all. Thank you, Professor Oliviero. And we use this technique about the contact angle in for determine or the affinity between the aggregate and bitumen, or the polarity of the bitumen. In this slide we show the procedure that you use to realize the contact angle, the preparation about the sample to the contact angle to determine the affinity between stone and bitumen. In particular, it's very important. We have the surface of the stone is very smooth, and the particular condition is described in this slide. In particular, when you have the good, the high affinity between the stone and bitumen, the drop of the bitumen, the angle, the internal angle of the drop between bitumen and the surface of the stone is low. When you have the high angle, internal angle, the high value about the internal angle of the drop, you have the worst affinity between bitumen and stone. For this reason, when you tested the effectiveness of the additive, I want that the internal angle is the low. It's very low. When you the difference between the last step and the first step is around 0, I have the good results. When the difference between the step 2 and the step 1, and I reported in this slide, we have when the difference is high, the affinity is no good for our sample, and the additive is no good additive for the adhesion promoter. But today I want to speak about the new mode that you use this technique, the contact angle, to determine the polarity of the bitumen. In particular, we use in the slide I put the mathematical model to determine the gamma P and the gamma D. The gamma P is to the parameter to use to determine the gamma P give me the information about the polarity about the bitumen. In particular, when I use the several solvent to determine the contact angle between the solvent and the bitumen. In the literature, we can find the typical value about the gamma P and the gamma D of the singular solvent, and I report in the slide. If you can see, I realize the straight line about the value in the graphic. We report the straight line, and in the graphical model I can I can give the information about the polarity, because the slope of this straight line is the slope value of this straight line is for me the give me the information about the polarity of the bitumen, while the intercept point of this straight line give me the information about the apolarity value of the my bitumen. In the last slide we show the results about this. You can see that the have the behavior. You can observe the behavior about the polarity parts and apolarity parts of the bitumen. This method we think that it's important to evaluate in the future the warm mix asphalt, because I repeat that the warm mix asphalt is the surfactant, and for this reason we think that the surfactant change the polarity of the bitumen in the surface. For this reason we think that when I put this additive in the bitumen, the surfactant, the interaction and the interaction between surfactant and the stone change the viscosity of the about the conglomerate, the asphalt, the final asphalt, because I repeat, don't change the viscosity of the bitumen, but change the viscosity of the asphalt. In this case, we can reduce the temperature of the road pavement produced. I complete with Professor Oliviero.
Thank you very much for the attention. So this, just to mark this topic is very new in the chemistry of the bitumen, and we try, because there are some experiments in progress, to try to understand the mechanism of this technology. In our opinion, we have to look at the surface property of the bitumen in terms of the polarity and dispersion of the surface, to understand the interaction bitumen and aggregate, and also by the scratch test is very new, because nobody did until now, and by this profile of the curve that I showed before, is possible to understand the interaction bitumen and aggregate. And this topic is very important, is the key, the principal key of this mechanism. So in our opinion, we can say until now, use the surfactant that change the polarity of the surface, and the goal will be reached. Thank you for the attention, and I want to thank everybody. Bye.